we are going to learn the properties of normal distribution. If you look at my slide, you can see a triangle and I have drawn a center line, isn't it? And now the center line is found to divide my triangle into two equal halves. That means the triangle is symmetrical at the center. Whatever you see on the right side of the line, the same thing you see on the left side. If the total area of the triangle is 100%, then the right side triangle occupies 50% of the area. The left side triangle occupies 50% of the area, right? So now I'm going to remove this triangle and I'm going to bring the bell-shaped curve here, right? The right side portion of the triangle is removed. Now the left side portion also removed. Now still you can see, the center line available. Now this center line, will divide your bell-shaped curve into two halves, which means the bell-shaped curve is symmetrical at the center. If the bell-shaped curve is symmetrical at the center, what will be the area of the curve to the right side of the center line? 50% area available. Hope all of you agree with me. Similarly, the left side of the center line, 50% of the area is available. And this 50%, majority of the area is available close to the center line, which is indicated by the blue color line. Hope all of you could observe that. Isn't it? A major portion of the curve is available in the form of blue color, which is, near to the center line. And what percentage it is? 34.1. Whatever you observe on the right side will be applicable on the left side also, because your curve is symmetrical at the center. So another 34% here. So the blue color area is measured to be 68.27%. Hope all of you understand this. The blue color area is measured to be 68.27. Now I want to include some more portion of the curve, right? I come up to this point, right? And come up to this point. And now another 13.6% is included. This side, another 13.6% is included. I want to go further. When I move away from the center, I wanted to have some measurement. How much distance I am moving, right? And for the first case, I moved by a distance equal to 1 sigma. I moved from the center by a distance equal to 1 sigma. And now the brown color area, 1 more sigma, 2 sigma. And now the green color area, 1 more sigma, 3 sigma. I moved away from the center by a distance equal to 3 sigma. Now I realize only a very, 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 very meager, small portion of the curve is available beyond green color. So I don't want to analyze beyond the green. So I would like to conclude by considering this point. What is this point? Point at a distance of 3 sigma from the center. This point I am going to consider as the extreme output from the process. Actually, no, the curve goes up to infinity. Up to infinity on the right side, up to minus infinity on the left side. It will never touch the axis. It appears as if it is touching, but actually it will never touch the x-axis, right? Always the curve will be an asymptote to the x-axis. So up to 3 sigma, the extreme output comes here. This point I am going to call it as upper control limit. You remember in the landing example, the extreme landing is called the upper control limit. Here statistically upper control limit can be located by moving away by a distance of 3 sigma from the center. This is upper control limit and this side is lower control limit. When I include all the area, up to control limit, see, there is 34%, there is 13%, there is 2%, and similarly on the left side. When I include all the blue color area, brown color area, and green color area, what percentage of the curve is covered now? 99.73% of the curve, will be covered within the control limit. That means 99.73% of the points will lie inside the curve, between the control limits. Suppose when I consider only up to 2 sigma limit, the 2 sigma limits are called warning limits. Now I am concerned about only the blue and brown color area on the right as well as left. So when I consider the 2 sigma limit, that is a warning limit, 95.45% of the area of the curve is covered. When I consider only 1 sigma limit, that is the blue color area alone, 68.27% of the area of the curve will lie within 1 sigma limit. So this is an important property of normal distribution. So if I know where is my control limit, it simply means I have understood about 99.73% of the outputs that are going to come out of my process. Because my process is normally distributed. How do I know? My process data is resembling a bell shape. So my process data is normally distributed. Whenever my process data is normally distributed, I will immediately conclude that 99.73% of the outputs that are going to come from the process will lie inside control limit, right? So I can predict about the output, if I know the control limits from my process, right? The other properties of normal distribution are the mean, mode, and median all are equal. If you calculate the mean, median, and mode, all of them will be equal or will be close to each other. If it is close to each other, it is approximately normal. If it is exactly equal, it is a perfect normal curve, right? The curve is symmetric at the center. Exactly half of the values are to the left of the center and exactly half of the values are to the right of the center. And always the total area under the curve is 1. In terms of percentage, it is 100%. In terms of probability, we say it is 1. Suppose in terms of the TPM, PPM, you can consider the total area under the curve as 1 million. 1 million is 10 lakhs. 1 million means then the 50, what do you call? Half of 0.5 million will be on the right side, 0.5 million will be on the left side, right? Hope the properties are clear to all of you. So these are the properties of normal distribution. Are we good in this slide or any questions?